first game is Pierian Spring. For this game I chose to tackle the pathfinding challenge for when the goblin is chasing the player, and also for when the gnome returns home. I decided to use the directional buttons for movement, as I felt this would be smoother for when the player is moving. When the player bumps into the gnome, what happens is it changes the gnome into a goblin, which I programmed through different states, and it also adds the player's position into a list of goblin movements, which the goblin then follows. Every time the goblin moves, it does a check to see whether there are any alternate paths, such as crossroads. If there are, it then changes the goblin back into a gnome, and it again follows the list of movements, but starting at the end and working backwards until it reaches its start position. The list of goblin movements which it follows should now be empty except its first position. If the goblin catches the player, it sends the player back to the start and changes back into a gnome, and again follows its path home. For the maze, I used what we did in class, such as the is hedge method, so that the player can't walk through hedges, and also use this method to create another is path for when the goblin is checking if there are any other routes. Initially, the maze was set up at random positions. However, this meant that there may not be a path for the player to get to the end. It also meant that I couldn't set up my characters in set positions. To solve this, I simply input where I wanted each part of the maze to be, and so manually set it up.
The next game is air hockey, where the player controls their puck with the gamepad. For this, I decided to tackle the collision detection challenge, and so used the full collision response code from the tutorials. In this, the player fires off their puck by pressing Y when it is in the direction they want, whereas the target moves off at a set speed and direction. I then added borders around the edge of the play screen so that when the disc collided with them, they would rebound at the opposite X or Y angle depending on which border they hit. I also have collisions between the target and player puck, which works off the line of action between the two. The final game is Predator, in which I decided to design the full game. First challenge was with the scrolling background, and so to solve this I created two rectangles which would decide when to scroll left or right depending if the player went either to the far right or far left. When the background was scrolling in this way, I then stopped the players' and other characters' movement to create the illusion they were still moving. Also, to make the game different each time, I created a random variable which would pick a random background out of the different ones, then add it to a list of 12 which would then be used during the game. I did this so that the background wouldn't change if the player flew back for a roosting tree. Another challenge was with the roosting for the bat, as it should roost when it goes close to a certain branch from the backgrounds. Do this by using the directional buttons to move and then R to roost. To solve this, I had to create 3 rectangles which were relative to the 3 different backgrounds, and set them at the position where the branch is for when the right background comes on. I also placed a roosting tree background at every 4th interval so that one would be relatively close to the player. For the sonar, I used the image given in the game specification, but then changed the distance between the circles so they equal, and then created an animation from it. Then created a boolean for the bat to say when it could use its sonar, which would change when it caught an insect. When the sonar hit an insect, it would increase its Y value only so that it moved down the screen. For when the owl catches the bat, I created a state in the owl class, flying or catch bat. When it catches the bat, it sets the bat active to false, and then the owl will continue to fly off screen. When the owl is chasing the bat, I will increase or decrease its position values whilst the bat isn't roosting, and then when it intersects, changes the state to catch bat. For the dragon, I decided to have it so that when it's active, it would work out the distance between the owls and bat on screen, depending which is closer will chase them. When their Y values are equal, it will breathe fire in that line, which will move towards the edge of the screen. If this hits any of the other characters, it will create an instance of the explosion which I have taken from the Microsoft Shooter tutorial. When the dragon catches an animal, it will also create an instance of the explosion.